Welcome to the School of Life. Life is hard, but you have got to be harder. I am Mrs. Collins, your life coach. Let's get started with Unit 2, Lesson 3. In this lesson, we are going to write equations of parallel and perpendicular lines when our original line is given to us in slope-intercept form. Our essential question is, how do you write the equation of a line that is parallel or perpendicular to any line? So, as we go along with our steps, it says writing equations of parallel and perpendicular lines. How to write equations of lines. First, we'll need to figure out the slope that we need. Then, we'll set up our equation in y equals mx plus b form. We'll plug in the point for x and y. And then we're going to solve for our b in our equation. Finally, we'll write our equation in y equals mx plus b form. So we have example 1. We have a line that passes through 12, 5 and is parallel to the graph of y equals 2/3 x minus 1. We want to know what equation represents the line in slope-intercept form. As a visual aid, let's see what this looks like. So we have a line that passes through the point 12, 5. A line that passes through the point 12, 5. The point 12, 5 would be located here. So a line passes through that point, and it is parallel to the equation y equals 2 over 3x minus 1. And that's the line that's shown here in red. So we have another line that passes through the point 12, 5, and it is parallel to this first line. So let's draw it in. It looks about like this. Okay. So what we want to do is actually figure out, well, what is the equation of this blue line? So here's our steps. Very first thing, we're going to need to know, well, what will the slope of that new line be? What is going to be the slope of our new line? So in this case, we're given our original equation, y equals 2/3 x minus 1. From this equation, we must identify the slope. So the slope of this original equation, we know to be 2/3 x. Okay, and we know that because 1, our equation is in slope-intercept form, and that means that the equation has been solved for y. And so the number that's being multiplied by our x is our slope. So m is equal to 2/3. They've given us that our new line is parallel to the original, y equals 2/3 x minus 1. So there's a couple of things that you know now about your new line, or should know about your new line. Since the new line is parallel to the old one, y equals 2/3 x minus 1, then that means that they'll have the exact same slope. So our new line has a slope of 2/3. Another thing that we know about our new line is that it goes through the point 12, 5. So we know two things. Our new line has a slope of 2/3 and it goes through the point 12, 5. This is just the right information, just the right amount of information that we need in order to come up with our new equation. So we've identified part 1. We figured out the slope that we'll need. We'll need a slope of 2/3 for the new line. Step 2 is to set up y equals mx plus b. So I'm going to write y equals mx plus b. Step 3, I'm going to plug in my point for x and y. So they gave us the point 12, 5. 12 is our x coordinate, 5 is the y coordinate. And we also have our slope, which is m. m equals 2/3. So I am going to replace our y in our equation with a 5 equals our 2/3, which is our slope, and our x value, which was a 12, and then plus b. What we need to do is solve for b because that'll be our new y-intercept for our new line. So far we've also completed step 3. Now solving for b is step 4. To solve for b, we have 5 equals 2/3 times 12 plus b. 2/3 times 12 is... Let's try out example number 2. A line passes through the point 1, 8 and is perpendicular to the graph of y equals 3/4 x plus 1. What equation represents the line in slope-intercept form? So first thing we should do is identify the key word in this problem, which will be our perpendicular. Think about what perpendicular represents, or what do we know about perpendicular lines? Well, you should know that they have opposite reciprocal slopes. Perpendicular lines have opposite reciprocal slopes. The next thing we should do is look at our old equation, or our original equation. And in the original equation, identify the slope of your original line. The slope here is 3/4. So our original line has a slope of 3/4. This is going to help us to figure out the slope of our new line. So that paired with the word perpendicular here. So our new line is perpendicular to the original. So our new line will have the opposite reciprocal slope of our original. So then that means that our new line has a slope that is a -4/3, because -4/3 is the opposite reciprocal of 3/4. The other important detail about this new line is that it goes to the point 1, 8. So we have 2 pieces of information that we're able to use to figure out the last parts of our equation that we'll need in order to write for this new line. So y equals mx plus b. We have an x coordinate and a y coordinate in our order pair here. And so we're going to use that and plug it into y equals mx plus b. So we have 8 equals our slope, which is a -4/3, times our x coordinate, which is a 1, plus b. So from there, in order to solve for b, we're going to go ahead and multiply -4/3 times 1, and that will give us -4/3, plus our b equals 8. Okay, from there, we need to add 4/3 on both sides of our equation. So we'll get b is equal to 8 plus 4/3 will give us 28/3. All right, so then at this point we have the m, which is our slope of our new line, which is -4/3. And we have the y-intercept of our new line, which is 28/3. So we write our equation. Our equation is y equals -4/3x plus 28/3. And this is our answer. For those of you using a calculator, when you calculated 8 plus 4/3, you may have gotten 9 1/3, or 9.33333. That is the same as our 28/3. However, we're writing it exactly. We're not rounding that particular decimal. For those of you who just need a quick snippet of, well, how did she get that? If I was doing this by hand, how would I get 28/3? So here we have the 8. We were adding it to 4/3. We'll look at 8 as a fraction, so 8/1. Okay, when we were learning how to add fractions way back in the day, we needed to add fractions with a like denominator. So here we have a 1 and a 3. A like denominator for 1 and 3 would be 3. Okay, and that's our greatest common factor for 1 and 3. So in this case, 1 goes into 3 3 times. 3 times 8 will give us a 24. 3 goes into itself once. 1 times 4 gives us a 4. So really we're adding 24 thirds plus 4 thirds. And 24 thirds plus 4 thirds gives us 28 thirds. And that's how we got that answer. So again, 8 plus 4 thirds is 28 thirds. And once again, if you're using your calculator, 28 divided by 3 gives you 9.333 repeating. All right, for practice problem number 3, we have a line passes through -3, -1, and is parallel to the graph of y equals 2x plus 3. What equation represents the line in slope and intercept form? For this one, I would like for you to pause your video. You can look back at the examples for numbers 1 and 2, but you are to work on number 3. So pause your videos. And here you have your answer. The new line, based on the information that they gave you, you have it's parallel to y equals 2x plus 3. The original line has a slope of 2, so your new line has the exact same slope, 2. And then it also goes to the point -3, -1. When we plug everything we have, our y, our m, and our x, into our equation, we solve for our b, and we get that b is equal to 5. So that means that our new line has a slope of 2 and a y-intercept of 5. So our equation is y equals 2x plus 5. And you're done. Example number 4 is another U-try problem. So a line passes through -2, 1 and is perpendicular to the graph of y equals -4x plus 1. What equation represents the line in slope-intercept form? Once again, pause your video and try the problem. All right, so your answer for this problem should be y equals 1/4 x plus 3 over 2. If you wrote 3 over 2 as 1.5, that's the same thing. If you wrote it as 1.5, that's the same thing. As well as if you wrote it as 1.5, that's the same as 3 over 2. Okay, just showing you the work to the side as far as how you deal with that fraction. What we needed to do there was add 1 plus 1/2. So once again, think about 1 as a fraction, 1 over 1. And then let's convert these fractions so that they have a like denominator. So our common factor for 1 and 2 here, greatest common factor will be our 2. 1 goes into 2 times, and then 2 times 1 gives us 2. For the bottom, 2 goes into itself once. 1 times 1 gives us 1. Okay, we are adding the two fractions, so 2 over 2 plus 1 over 2 gives us 3 over 2. And that's how we got that 3 over 2 as our fraction. And one more thing to point out, just in case you're looking over your work, -2 over 4, from this line we jump to 1 equals -1/2 plus b. -2/4 was simply reduced to -1/2. Okay, so please make sure that you pay close attention to each line and note what happened as we went from line to line. All right, so the very last part of our lesson will be to talk about two special lines, horizontal lines as well as vertical lines. So as a reminder, horizontal lines have equations that look like y equals some number. Vertical lines have equations that look like x equals some number. The number that's filled in here for our horizontal lines is the y value, or in other words, it is our y-intercept. So y equals, and then we're looking at the y-intercept. Where does our line cross over the y-axis? For our vertical lines, x equals a number. That number happens to always be the x-intercept. Just as a quick note, our horizontal lines look like this when they're graphed. And your vertical lines are straight up and down when they are graphed. Okay, so let's go ahead and look at some special equations. We have write the equation of the line through negative 3, 4, that is parallel to y equals 6. So let's go with just option A first. So first off, let's get a visual. Negative 3, 4. Negative 3, 4 is 1, 2, 3, 4. Negative 3, 4 is here. That's the point, negative 3, 4. We have a line that's parallel, or we want to write the line that's parallel to y equals 6. So y equals 6 is here. So this is the line y equals 6. Notice that the y-intercept here is 6. So this is y equals 6. On the y-axis, we're at 6, and we have our horizontal line. So that's y equals 6. What they're telling us is that we have a line that's parallel to this one, parallel to y equals 6, but it goes through this point. So if you think visually, then that's a line that looks like this. It's parallel to that y equals 6, and it goes through the point here, negative 3, 4. So to identify this line, you simply need to look at its y-intercept. The y-intercept is a 4, so this equations for this one would be y equals 4. And we're done with part A. Part B says that we're writing an equation of a line through the same point, negative 3, 4, which is here again, and that line is parallel to x equals 2. So let's go ahead and draw in x equals 2. So we go to x equals 2 on the x-axis, and this time this is our vertical line. So x equals 2 is vertical. And we have a line that's parallel to it, but goes through our point, and our point again was negative 3, 4. So in this case, we are going to visualize it. It looks like this. It's parallel to the blue one. And then we identify the x-coordinate for our red line. The x-intercept for our red line would be a negative 3. So this equation would be x equals negative 3. All right, part C. So write the equation of a line through the point negative 3, 4, which is here, same point, and it's perpendicular to y equals negative 1. So let's go ahead and draw in y equals negative 1. Go to the y-axis and go to your negative 1 here. And y equals a number will be a horizontal line, so go straight across. And this time, we want to write the equation of a line that's perpendicular to this yellow one that has been drawn. So perpendicular. That means it'll create a 90-degree angle. So 90-degree angle for a horizontal line would be a vertical line. So here we go straight up and down. And since this is our vertical line, that means that we want to identify the x-intercept. And the x-intercept, this line crosses at the x point, which is a negative 3. So this answer would be x equals negative 3. All right, and then our last one for this problem. Write the equation of the line through negative 3, 4. Again, it's plotted. That is perpendicular to x equals 5. Well, let's go ahead and draw an x equals 5. So go to your x-axis and write the point 5. 1, 2, 3, 4, 5. Which is here. Since it's x equals 5, that means that we will have a vertical line, so straight up and down. And then our point here is perpendicular. The new line is perpendicular to our original line here, the red one. So therefore, we're going to draw a horizontal line because it's perpendicular to our vertical line. And this time, it crosses through the y-axis, and it crosses through the y-axis at 4. So 1, 2, 3, 4. So this would be y equals 4. Now, I don't know about you, but there is a pattern going on here, and I don't know if you've figured it out yet, but here it goes. Whenever you're asked to write the equation of a line that is vertical or horizontal, the answer is very, very simple. So it goes through the point negative 3, 4. and it was parallel to y equals 6. If it's parallel to y equals 6, then that means the new equation is going to start off with y as well, and then it'll simply be the y coordinate within your order pair. So y equals, in this case, our 4, because that was our y coordinate. It was parallel to x equals 2 for our second one, and so the second equation will also start off with x equals, and then you'll simply identify the x coordinate from your points, which is a -3. So x equals -3 was our answer for part B. So parallel is very, very straightforward. Y is the starting point of the equation, y for the equation that you want. So y equals 6 was the original, y equals 4 will be our answer. Again, our y coordinate is 4. X equals -3 is our answer for part B. Again, because it's parallel to x equals 2, so both are going in the exact same direction, x and x, and then our x coordinate is a -3. For C, perpendicular to y equals -1, go with the opposite. So if it passed through the y-axis for our original equation, it's going to pass through the x-axis for our second equation. So y equals -1 was the original. So x would be the starting point here, and then go with your x coordinate, which is a -3. So x equals -3. For D, perpendicular to x equals 5. So what we want to do is note that, well, they're perpendicular. One goes to the x-axis, the other goes to the y-axis. And you would simply pick out your y value from your order pair. So y equals 4 for this answer. With that being said, you just might be able to answer the 2 U-Try problems without graphing. Try it. Please pause your video and answer parts A and B. And your answers are given. So parallel to x equals -1, but it went through the point 2, -5. So our answer would be x equals 2. So parallel and parallel, they both are going to go through our x-axes. So therefore, our answer will be our x equals, and then choose your x coordinate, which is 2. Part B, perpendicular to y equals -6. Well, one is, the original is going through the y-axis, so then the other one needs to go through the x-axis. So y equals -6 was the original, x equals, and then pick out your x coordinate from your point, which is 2. So x equals 2 is your answer for number 2. And that concludes this lesson.